Laura. The freshest, most radiant creature God ever created. 18 when I married her, Marty. 25 when she died.
Well, hello there. This is the 8th part of a series of streams where I'm trying to make a 4K intro. That is an intro in 4 kilobytes size, that executable file of that takes only 4 kilobytes. And it's supposed to draw a lot of graphics and synthesize music, and basically what you are seeing here is the early prototype that I've been working on for several streams already, but well, basically it will be something like that. It's an only scene. Anyway, this is a slight introduction for this whole part. This stream, I'm making this series of stream both in English and Russian, and this stream will be mainly in English, unless there are many Russian-speaking viewers who decide that it's better that I will be streaming it in English, in Russian. Anyway, this stream is in English, and basically, obviously I'm not a native speaker, but I will try my best to explain what I'm doing in English. What we are doing here now basically is we're making a demo tool that will allow us to edit live code the intro itself, to make very quick changes, basically to change stuff on the fly and see what it does. Here's an example of what I'm talking about. Like I can uncomment things here and you will see the changes immediately. Yeah, something like that. But currently we have only a basic setup where I can change this shader. This is a fragment GLSL shader that draw this scene. Basically, it's ray tracing. Well, not ray tracing, this is ray marching setup, where this object and this whole scene is declared in terms of distance function. Anyway, I will not go in much detail right now, because I'm just trying to like introduce you to this thing I'm doing right now. And if you need more details, I think you should watch the earlier streams, but well, most of them are in Russian. Anyway, so today, for the past couple streams and today we're going to continue working on this tool, and today's plan is to be able to add this support of frame buffers to this tool, so we can have multi-processing, like post-processing and effects, and like baking some textures or something like that. Last time, the 7th part of the stream was about adding the texture support here. So we added a random texture, and this another thing that I want to like let you know here is the system that we got in place here. It's a kind of a node-based system, so there are some nodes that represent some kind of object, state or value, and they also have an information how to reconstruct this state for the most part. So there's this string object that contains strings that are mainly used to represent the shader sources. There's this program node that represents the shader program, and it is fed a couple of strings here. And there are uniforms nodes that represent some constant that we can put into that you can feed into shader program to, well, as a uniforms if you are familiar with GLSL. And there's this texture node that is also can be used to be fed into shader program. Then there's random texture that is used to generate random texture. Then there's a draw node that represents a draw operation. Basically, its purpose is to draw something into frame buffer, but it doesn't actually know a thing about where it's drawing. It's fed targets here. And there's a frame buffer that we started to write last time, but I was kind of sick, so I couldn't finish it. Had to terminate the stream early, and I think I hope that we will finish it today and try to do at least some post-processing. So Another technical thing about this is that I'm not using OpenGL directly here. I have written a small wrapper that hides all the, like, most of the crappiness about OpenGL, like not the most, but some of it. And I'm really happy to use it instead of OpenGL directly, but I think that for us to make frame buffers to work today, I will need to to go into this framework and change some things to, well, so we'll work with bare OpenGL today too. And a couple technical things I'm asking if anyone is watching here right now to check whether you can hear me okay, and if there are any issues with frame rate or any technical issues. Well, as usual, I'm not seeing anyone watching this, so I will be streaming it like for the record, and if okay, I hope at least a few people will show up today, because it's not usual time for me to stream. I usually stream like in my evening, and I have mainly Russian speaking audience there, and these morning streams are well, it's only, I think, the third morning stream that I'm trying to do in English. The idea here is to have English speaking audience to like watch this too. Anyway, I think I will start implementing what I was talking about here, and we'll see how it goes. So the frame buffer. Last time I was thinking about the viewport and like making custom viewports. I don't think that we need that functionality here, and this is a generally bad idea. Well, it's not bad, some things do require it. Like I read this recent paper about thousands of lights in a scene, and there are some clever tricks of tiling the viewport, tiling the final image into like these viewport frustums, where you optimize the lighting alongside the frustum. And well, we won't be doing anything like that here, so well, I think we should put 0 here. So basically we guarantee that the whole frame buffer should be rendered. And this resize here is not needed anymore with the X and Y arguments. So the frame buffer, basically I'm thinking about splitting it into two classes, like the basic node frame buffer class that encapsulates the target, the draw operation, and that's it. I think it shouldn't do anything else. Like, this is really basic. So this is the base frame buffer, and waste frame buffer, okay. So it shouldn't have any targets, it should have only resize and dirty and draw, and that's it. It shouldn't do anything else. So, and here the node frame buffer, that is like actual frame buffer, so it should be public node base frame buffer. So I'm not used to navigating to that. I should really do the Vim hard mode someday, because I'm like so bad at navigating. This is the frame buffer, and screen is also a node base frame buffer. So the base shouldn't do anything like at all, and target frame buffer is not supposed to do anything. I think this should be fine. So here, parameterize. Yeah, I think we should parameterize the clear, like, or should we? Like, when we need it, we will do it. Okay, we don't need it actually right now. And another thing here is to it would seem that like node screen is basically the node base frame buffer without anything. Like this is just it. That doesn't make any sense from like C++ perspective, because it's maybe we'll have some differences there, but I'm not sure. Anyway, I don't care that much. Frame buffer is... will it have to... well, basically these have to be protected, because we will... well, this one is private, and this one we will modify in frame buffer. Yeah. So the idea here is that we create node textures and then add them to this vector, and these are empty textures without anything, and probably we should also have dirty set to true here, and then on update, so we have this ball update. We need to basically we need to reallocate all the textures if we have anything changed about them. So at this point, we probably need to have some distinction about whether has anything changed. So, okay, anyway, if dirty is true here, then basically it means that either this changes, so we have some textures attached to it, some new textures, or the view changed, so the viewport size changed. And that means that for both of these we need to reallocate. And then and this means that there won't be any unnecessary texture reallocations, because the redraw here won't actually set dirty to true. It can't. It will be we will call it only here. So base from buffer updates. So yeah, this one will redraw a frame. And here we must do like for texture in targets. And here is the place where we update our target. So this thing here first is a format and second is the texture. And we need a way to specify the texture, to reallocate the texture here. So this needs dirty too. And this needs an update. Like upload. Format and pixels. Oh, we have that here too. And dirty will be set to true also. Why do we need dirty set to true? Well, because if yeah, we need that because and things can depend on this texture being dirty. So here's an update, right? Maybe we can like embed the dirty into this thing. How? Well, because basically what we need is this functionality, and we need it here, here, and also we need it here, and we could probably need it here we don't need it. Yeah. Frame buffer, it's slightly more complicated. Anyway, I think we should be fine with it as it is right now here. And also, as we have this function here, we can skip this call and just upload this texture with using this function. And this will do. So this should work, and then we can use this functionality here just to okay, this is a pointer. And the sizes here are Привет, Anton. Dimensions of the texture here are target, viewport, and target viewport. And the format here is text first, and we have no pixels here to set. So this should upload things. I'm thinking about the fact that currently this GL wrapper doesn't have support for multiple attachments. It is fine by now. Like, I think that we should basically assert on target size, targets empty, and we will add multiple targets at some point. What we need here is HL frame buffer. Okay. Frame buffer color is texture. Second, can we actually take the HGL texture? Probably can't, so I need to add these. And this should be a pointer. Depth, texture depth buffer mode. We don't need a depth buffer here at the moment. West. What does that mean? Depth. What does depth here mean? Depth mode not equal to FPS mode. So this is a flag. And this one can be only texture or best. And if we have okay, so basically the code here creates a def component anyway. Interesting. So if we don't have the depth mode to set the texture, and there is depth or color change, we need to reallocate the depth render buffer and attach it to the frame buffer. Okay, I'm not sure why I did that. Maybe on some platform, maybe there was some platform that required, or maybe that's just an assumption that if this is not equal to the texture, then it can only be the best AGL-DBM best, so it should like create some depth component and have it. And if here depth and depth mode is texture, then it basically detaches any depth if there was depth buffer. Okay, this is weird. So I think I have texture here and depth texture set to 0. This should avoid having any depth buffers. So another thing is that this node frame buffer should actually have dirty set to true, because we will need to run through this anyway. And also, although we probably should skip the update if there are no targets attached. Like if targets empty, we just should return false. Like we didn't update, we don't have anything, we should just quit. That would also mean that it would not mean a thing. I just thought about what will happen if someone has consumed the target, and they shouldn't actually happen, because like it wouldn't be empty. Yeah. Another thing is, I think we should have target set viewport, but have some reasonable defaults for viewport. I don't remember exactly. I don't want to like check OpenGL capabilities right now. I think we will be fine with 16 by 16 frame buffer. Probably we could do 1 by 1 pixel, but I can vaguely remember that there were platforms that have this minimal frame buffer size, and I'm too lazy to check. This actually this should be fine for all practical purposes. And so we have set up the frame buffer here, and it should. So let's just check that we have this whole thing done. As expected. I also think that we should actually switch on the OpenGL error check here, because I have added that recently to this tool. GL call, so what do we need to do? Add to GL debug, we need to define this thing before. So yes, define, yeah. Okay, so let's construct our development pipeline to this node frame buffer is the okay, frame buffer it is. Node draw, we need another node draw just to screen. Oh, draw to screen. Okay, we should start naming things accordingly. So here's node draw. Draw that actually should do like ray march. This is a ray marcher, and so this all ends up writing into frame buffer. So it should end up writing into frame buffer. I think this here should be a separate, like some common thing, and here we should have a separate program like this is a prog ray march fragment. Okay, let's name things differently. Ray frag, ray prog, and time resolution. Those are kind of common. Yeah, they should kind of common. And no, ray march. Ray draw. Okay. Okay. So and we will need to have node string file like post frag and node program post prog node draw post draw, and this is not needed anymore, and this basically will write the frame buffer. So we need like this node texture that is a pointer, that will, like, this is the frame texture. As you can see, here is this common thing, like this is a fragment shader that draws the entire screen, and this is another fragment shader that draws the entire screen. Probably it will be a good idea to have it grouped into some kind of like full screen node that draws full screen. When we will have, I think we'll have a couple of these full screen things, like besides these two things. I think there will be a couple more. And I think it will be a good idea to add that functionality at this time, like at that time when we have multiple things like that. So let's rename these things to, so basically the random texture is the first object that is created, and then we have time and resolution, also have this 16 pixel minimum, and then we have a vertex shader that is basically the like full screen vertex. This is common for all the programs that we have. And then we have a ray fragment. Okay, so we'll need to add another. There is like post frag, and this also like ray frag. This should be ray frag also. And this obviously is a ray program. We have the ray marching draw, that is ray program, and then we have some interesting things like the frame. It doesn't do anything right now, but it allows us to allocate the frame texture. So this is a frame buffer. And as I recall, this is the HDL texture format, and we will have, I think we should be fine with float 32. Right now it would be a better idea to have like float 16 or fixed point something, but I don't care. This is the only thing that the framework supports right now. And then we have this, and this we can just basically rename the ray to post, and it should be fine. And then we have screen, and screen doesn't do anything. Okay, so this draw here, this is the ray draw. And the screen will be drawn by the post draw, and the frame buffer will be drawn by the ray draw. And the post draw it should have the UV2 resolution, the same resolution. This is not necessarily so. I think at some point I would like to limit the ray marching resolution to something like 720p, just to not stress the GPU so that much. because we don't actually need that much of the details here. We will post-process the shit out of them, and they won't be like anything visible on like pixel scale of Full HD resolution. But this is the next thing to do, like after we get basic frame buffer running. And also the post draw will need a uniform consisting of the US2 frame that is frame texture. And as we have this managed resource here, like all these things are created as a value, not as a pointer or smart pointer or anything. Like they will be allocated automatically. Oh, I forgot about one thing here. Let me fix this. So, basically node texture needs to deallocate itself, and gel texture destroy, I think it will be destroy text, no pointer, okay. So, do we have any other resources that we need to destroy? Load. So the program, we destroy program, and I don't think all other resources are deleted automatically like this. This is just okay. Yeah, this is automatic. This is automatic. Uniform or just plain old data. Texture we fixed. Draw. Is there anything in draw that needs explicit deinitialization? I don't think so. A frame buffer, not at the moment. I will need to fix the frame buffer at some point, like to add multi-destination stuff to it, but in the end frame buffer object management, and then we'll need to manually destroy it. So the only thing left for us to fix here is to add the destructor here and manually destroy the... Can we like not do that? Can we like stick with std, what was it called? Unique, I think. Unique with a unique pointer or something. And then we just need to do the get here. Yeah. This looks okay. I think that this looks close to whatever. So we'll need to add another file that... Can we edit this together with this thing? Like post GLSL. It will need this thing here, these two things here. Why? I think, yeah. Let's do this frame, this also frame. Resolution, this is the final resolution, but here's the thing. I think that we should do it like this. frame resolution, that is UV2, and basically this is the resolution here. Yeah. Separate resolutions for the target frame and for the frame texture that's supposed to be that this basically is a source. And that means that we basically can separate the final frame resolution from the screen window resolution right now. Okay, let's do this like very simple. Frag color will be exactly the texture to the US2 frame and frag coordinates divided by the target resolution, UV2 resolution. And let's whistle colors just to check that we do work with frame buffer. Also, I think that we'll need to do linear color output here, and this post-processing thing will have to apply tone mapping and all this. Wow, this is dark. Okay. So let's quit this and yeah, okay, this will need to edit to like add this file. And we'll need to yeah, we added the OpenGL error check, and it started to complain to things that probably were faulty before. And you are complaining to the invalid enum about front face. So this is probably here the primitive. The front face is agile front counterclockwise. So we don't see anything. We can like debug it this way. We can add the random texture instead of frame texture to see that this thing like works at all. Whether this is... yeah, basically this works. But the frame buffer is not drawn. frame buffer is empty. Okay, let's do this right like this. Let's try to output it as it is. Do it like this. Valid value on GL draw arrays. Okay. This is interesting. Yeah. Basically it has the program and it can do anything. I am sure that I had the frame buffer working some time ago. There's this example in code that has the frame buffer working, so build links samples. Okay. Oh yeah, I need to update this. This is outdated. So basically this, and this is data now in DX. And this is all. Okay. This now needs LX fixes. Does it work? Yeah, basically I have the frame buffer working for this sample, but it doesn't let me look at it again, how samples would be, how we designed it back then. There's nothing out. That clears one, everything. Source. Draw and show and merge and screen of FB. FB textures, frame buffer params. So how do you set up here? Texture is 0, mode is texture, color is this, frame buffer. Okay. Okay, I know what I'm doing wrong. Basically the target here needs to have this set, and this is a pointer. Yeah. So no, that is sad. Well, this, I think we can do this even here. Like, this is basic. This is really basic. This should always point to this. And do we actually... So this is set on its constructor to 0. And then when we do draw, we do the draw with the target that we have here. So draw, yeah, target. And then we do texture. This is the same, color is the same. We do upload here and set it colors. With high. Another thing that we could debug is to like output all the OpenGL calls that we have here. I had it at some point. GL call. Like if .gl trace. This is a macro. I can't do that. Crap. Trace print. And else, if we don't need the trace, this thing will be empty, and this thing will be GL trace print, and then we can define GL trace, and because this will pollute the terminal a lot, we will need just after the first paint we will just exit. So let's see what happens here. So the frame buffer is generated, but it is generated for everything, and then we do the textures, shader source. Okay. This is only one program. I think what happens here is that this frame texture doesn't know that it depends on frame buffer. So basically we need to have frame buffer texture here. Where was it? No, frame buffer. So we need to define a node frame buffer texture that is public. Node texture, and the only difference here is that it knows about node frame buffer, and this is const. And its bool date. Well, basically it has the node frame buffer texture constructor that accepts this frame buffer. And well, basically it's remember what frame? No, frame buffer. remembers it and does nothing, and this one here basically just returns the node frame buffer, the frame buffer update. Well, this can be const basically. Okay, remove the unnecessary lines and this should be defined here, and then we should allocate this frame buffer texture and this and y. Well, okay, this is public. Well, yeah, this should work. I hope. Unknown format. What? Come on. How did this happen? So there's a definition for the F32 RGBA texture, but there are no like format support for it. I can't recall adding this stuff so many times here. Okay, GLTF internal format is GLGBA type GL. This is like, I can recall that this is not that straightforward. There was this I remember that there was like even platform specific difference, like on a Mac I had to do one thing and on Linux and Windows I had to do another thing. Okay, text image 2D, and this is the version of the OpenGL we are working with. Type and internal format is GL. So I think it will complain, but let's try it. Yeah. Format. So now I see that it does the frame buffer stuff and it renders something. So let's remove the quit at the first paint, and also let's remove the trace, and let's call it again, and nothing happened. Okay, let's try it with the default format for this. Let's do the HLTF, like basic, this one. and this doesn't work too. That's weird. Okay, let's see. Let's trace it with our eyes. Frame buffers generated. We generate the one texture and bind it and repeat. Basically, this is the same settings that we have here, so this shouldn't, like, this is the same. Well, then we create another texture. I think this is the random one, right? Hard to tell. So, shader source. This is some shader program gets compiled, and then we bin the frame buffer. So this is the point where the first array margin program gets traced, gets to draw texture, and then we set the viewport, and then we clear, and then we use program, and then we set the uniforms, and then we set the random texture, so it has been allocated somewhere, and then then we set the texture uniform, then the bin the buffer, the attributes, enable call face. Why? We don't need that. That we don't need. I don't think that it actually changes anything. But anyway, good to disable. So this is a draw operation, then we disable the attributes and disable the frame buffer. And then we set the viewport, like for the screen. Clear the screen, use the program. Set the uniform. Yeah, the uniform here is to like the resolution. But why is it the single resolution? I think I've added a couple of them there. So yeah, we have this resolution, this resolution. So there are 4 uniforms here, and here we have the 1 and 2, and that's it. Interesting. Why would that happen? So this gets set. This gets set. But this one isn't. Ah, yeah. Or no. Yeah, I know why is that so? Because the location for this uniform is not valid, because we don't use this uniform in the shader, so it's not set. Okay. And then we do set the attribute, and then draw, and then disable the attribute. So basically it looks sane, but we still don't get anything written to the Do we get the frame buffer complete status here? Yeah, I thought we have a valid status here. So the frame buffer is complete. Frame buffer is complete. I think that we should do this resolution here, because this is a frame texture. No texture. Resolution. Uniform to resolution. This resolution actually depends on this object. So if anyone uses it, it should Привет, Мару Инфантри. А чё не работает? В смысле, что фреймбуфер не работает? Да, не работает. Я не знаю почему. В соседней штуке там похожий код прекрасно работает. Вот какой-то отладочный фреймбуфер. Как всегда, какой-то тупняк. So, I think I just need to leave the comment here, like, fix me should depend on this texture. But this shouldn't make any difference for this part here. Like, we should fix it someday. But now it shouldn't make any difference. Okay, let's compare this with this again. Draw stuff is the same. Okay, let's check, like, sanity check, that we can actually, like, ray draw, that nothing is broken for screen. So basically this trace shader is empty. Can you like draw this? Yeah. And you are broken for... Okay. Let's check that frame buffer actually works now. No, frame buffer doesn't work. Okay. So we still draw white pixels into the frame buffer and nothing works. This is bad. If we now do the draw, we will get a white screen. So we have actually two problems right now. The first one is that frame buffer is not updated. And the second one is that the ray draw now draws black screen instead of the... Probably that's because the resolution here isn't updated as it's supposed to. Like, what if we do... this? Oh yeah, oh well. Frame buffer is... we need to resize it. Like, we need to resize it. We haven't done it. And then we have something. Yeah, well, we have the ray draw here. And well, basically it will work. And then, yeah, now the frame buffer works. It works with this resolution and this resolution. Well, this will be updated here, and I think we can start with now and like, yeah, these, yeah, basically the frame buffer works, and we now can try to do things. This is entirely post-processing. Okay, what can we do here? What can we do here? What's an some easy effect to check? Like we could do kind of we could do bloom, like create a separate texture. You can do a downsample texture, blur stuff into it, like do a single pass blur for it to be easy, and then like superimpose the blurred version on this thing. But you know what, I haven't actually read anything about post-processing effect before the stream, so this will be this won't be pretty. What we could do is like what I can do easily right now. So what I want to do in the final scene here is to have some depth of field effect. I will need a depth buffer for that, and I don't have it yet, and I don't actually want to start implementing it right now. I think that I will finish streaming in a few minutes, so like maybe half an hour of time left for me. So I'd like to do something live here, and there's this like depth of field bloom like effects to make use of HDR. Yeah, we forgot to do one thing here is this one, this one, and yeah, will it work? Yeah, it works. Okay, so we have the HDR. This is actual HDR. Like we can do a lot of like really weird stuff in here. So this is the light. We can have a lot of lights here. We will need to tone map things a lot. Here and here. And here I would like to try. I would like to try something like this. How do I start with? Okay. This is like this. I haven't read anything on bokeh, so I have no idea what I am doing here, but I will like try to come up with something from the top of my head. It won't be pretty, but we'll try, and I think this is the last thing that we'll do today in the stream. Also, all of this code that I'm working on is on GitHub, and I will be uploading what we have done today after the stream. So if you're interested, you can ask for the URL. So this is the starting point, and this is the radius. And we don't modify the radius, so I think we can do like for R, how many pixels I would like to, like how the radius of this effect will be. Like this size radius of the influence. Okay, let's go with 20 because why not? And then I think I'll need to max number of samples. Let's go like with 64. And so now I need to come up with a sampling function. There are some really good ones that rely on the generate uniform samples on the hemisphere or something like that, but I don't remember and I don't want to look them up. So what I will do is I will add sampler 2D used to rand and to rand resolution and bring all this crap to here too. This is another thing that we will want to do, is to have common stuff in headers and then write something like this, but this will be another time. So for now it's just copy pasting things. Okay. And I don't have the random here. I will need to update the tool to have the random texture here too. Okay, let's do this. Let's do this right now. Basically, I just need to add this here and replace ray with post. And then I need to quit and restart the tool. Also, this function here doesn't care about aspect. We'll fix that too. Now vector v is the I think we'll be fine with that right now. This is not in any way correct, but well, we'll need to come up with some mapping of the frame buffer to the screen. So the sampling point is point P plus R multiplied by hash of value of okay, let's try this now. And this should be the like this. This should be vector 2 like this, and this will be like this, and it should be all fine. No? 26. Yeah, like that. And then what we do is we do the US2 frame. Plus S divided by U2 frame resolution. And this shouldn't actually work because this will look like just a cheap blur, right? Right? Yeah, this this is kind of bloom-ish, so can we do like the radius higher and number of samples higher? Okay, this is silly. Probably there are some basically should work like we should avoid do we need like to explicitly avoid the dark pixels? Or... Привет, геккерка. Да, на стрим, но стрим уже близок к концу, к сожалению. Я уже стримлю 1:40 минут, и я начинаю уставать, и у меня закончился контент, к которому я хоть как-то более-менее готовился. Так что... Ну, я думаю, следующий стрим скоро. И основной язык этого стрима английский. Следующие, я думаю, будут на русском. Ну как скоро следующий стрим? Я думаю, может быть послезавтра вечером, что-нибудь такое. Anyway, so the thing here that I have no idea how to do the bokeh effect properly. I will have to read about that and try some things. From now, it looks like the post-processing setup works, and this is great. So, I think I will be wrapping this up for today. Next time I will read about the post-processing effects and like come prepared, and we do a couple of those. Maybe we'll fix even a depth buffer and do the depth of field effect, and basically we'll do all this crap that is supposed to like spoil the picture, this cheesy stuff. We'll do all of that. And I think this is it for now. Yes. So thanks for watching, if anyone had watched this, and I will see you next time. Probably I will stream tomorrow evening, I think, and the stream will be in Russian, so hear that. Так, и на русском я тоже самое скажу. Значит, до следующего раза я прочитаю все-таки про эти все эффекты. Значит, следующий стрим, скорее всего, будет послезавтра вечером, если у меня получится. Он будет на русском, и, значит, мы поделаем всякие эффектики сюда. Вот. Как-то так. Ладно, всем спасибо, всем пока.